Hello. Today's lesson is about square roots. We're going to talk about simplifying expressions, we're going to rationalize denominators, and then we're going to do some algebraic operations on square roots, also known as radicals. So first, let's talk about the definition and get accustomed with some of the notation. When we see the square root of a, understand that that means the positive square root, also known as the principal square root, but it means the positive. So if we want the negative square root of a, what would we write? Well, it would simply be negative root a. And if we want both square roots, you could probably guess plus or minus root a. All right, so that's a little bit about the notation. Two other things are the product rule and the quotient rule. So if you could pause these and kind of figure out what goes on the other side of the equal sign. Root a times root b would be the root of a times b. And then conversely, if we already have a product inside the root, we could break it into the product of the two roots. And then the quotient rule, again, see if you can figure out what goes on the other side of the equal signs. So the quotient of two roots is the same as the root of the quotient, so root a over b. And if we have the root of a quotient, it's the same as the quotient of the roots. Okay, so let's get into our first little task here, and that is simplifying square roots. And we're going to kind of use the idea of the product rule to do this. So if I want to simplify this root, what I'm going to do is I'm going to break it into factors. So this is technically root 36 times root 2. That's what root 72 is. And I chose 36 because it's a perfect square. Times the square root of x squared times the square root of y squared times the square root of y times the square root of z to the fourth. So notice wherever possible, I tried to make sure that I put a perfect square inside the root. So the square root of 36 is 6. The square root of x squared is x. The square root of y squared is y. The square root of z to the fourth is z squared. And then the things that I could not take the square roots of still stay inside the root. So that would be the 2 and the y. So that is the simplified form of the square root of 72x squared y cubed z to the fourth. Rationalizing the denominator. Now, if you recall, root 6 is an irrational number. And what happens is there's a standard that basically says a fraction is not simplified if the denominator is irrational. So we have to try to make it rational. And the way we do that is we multiply the fraction by 1, but it's a cleverly chosen 1, essentially root 6 over root 6. So now what happens is as I multiply, I get 9 root 6 over the square root of 36, also known as 6. And now we can simplify 9/6, so we end up with 3 root 6 over 2. And notice that the denominator is now a rational number, because 2 is a rational number. When we have a radical expression in the denominator with more than one term, we're still going to multiply by 1, but we've got to be a little more clever. And we multiply by something called the conjugate. So we multiply by 4 plus root 7. And the goal there is, again, to get rid of any roots in the denominator. And we know from factoring and like the difference of squares that multiplying by the conjugate, the 4 plus the root 7, is going to eliminate any middle terms and ultimately eliminate all radicals. So in the numerator, I get 12 plus 3 root 7. In the denominator, we would FOIL that out. So 4 times 4 is 16. 4 times root 7 is positive 4 root 7. Negative root 7 times 4 is negative 4 root 7, so they cancel out. And then negative root 7 times positive root 7 is just negative 7. So in the end, this is 12 plus 3 root 7 over 9. If I factor a 3 out of the top, that'll cancel with the 9 in the bottom. So this is just 4 plus root 7 over 3. Again, notice the denominator is a rational number, no roots. So that's why we call it rationalizing the denominator. Lastly, let's do a few algebraic operations. So in order to add roots, they must be like. So we can add a root 2 to a root 2. We can add a root 7 to a root 7. So in order to see if these are like radicals, we should first simplify them. So root 18, I'm going to think of that as root 9 times root 2. So that just gives me a 3 root 2. Root 50, I'm going to think of as root 25 times root 2. So that's just 5 root 2. And then root 12, I'm going to think of as root 4 times root 3, which is just 2 root 3. So notice I have a few root 2's in there, which I can combine. So if I've got 3 root 2's and I add 5 root 2's, that gives me a total of 8 root 2 minus 2 root 3. And that's as simple as we can get that because we cannot add the root 2 and the root 3. And now for multiplication, we're just going to distribute as if they weren't radicals. So I'm going to take the root 3 and multiply by the root 15 and get root 45. Notice the product rule in action there. And then the root 3 times the root 6 is a root 18. And now I'm going to simplify these. Root 45, that's root 9 times root 5. So 3 root 5. And then root 18 is root 9 times root 2, which is 3 root 2. Root 5 and root 2 are not like, therefore can't add them up, and that's as simple as it gets. And that's it for square roots. Thanks for watching.